Hi folks, here's another quick one on IPv6, and this time it's the rather common misconception that IPv6 is actually a network topic, which it isn't. Not really. And why is that? Okay, let's take a look at the traditional TCP IP stack and what it looks like. Now here you see a schematic which shows what the TCP IP stack is supposed to look like. Several protocol layers, and there's the network layer with new IPv6, and the general rule that each layer only talks to the layers immediately above and below. So IPv6, which is purely a network layer protocol, only talks to the transport layer and the link layer, and that makes it a network topic, right? Well, actually not quite. First, you have to sort out IPv6 in the network layer, fair enough. But once you do that, or once you've finished that, or once you have taken care of these things, the fun only starts. And why is that? Because the TCP IP stack is supposed to be designed such that every protocol only talks to the protocol layers above and below. But unfortunately, due to a minor design flaw, IPv6 doesn't do that. Or the network layer as such doesn't do that. Or, well, the application layer doesn't do that. Why is that? Because every once in a while, even the application layer has to talk to the network layer through the transport layer, and that's anytime the applications have to deal with IP addresses, which is a major pain and quite a design flaw. Well, we know these days, people didn't know 40 years ago. And that leads to a slightly different situation. Well, this diagram is perfectly correct from a systematic point of view. It's completely missing the point when it comes to IPv6 deployments. And for that, I have a slightly better diagram which looks like this. Yeah, that's not quite standard, but it actually hits the point. So we have the network layer, which is this tiny little red thing, and it's still not drawn to scale. And this is where everything has to go through. Physical layer is a bit more complicated, especially if you think beyond plain vanilla Ethernet, maybe about deep sea cables or satellite links or whatever. The transport layer, especially with TCP and SCTP, is significantly more complex than the network layer. And then there are the applications. And the applications which have to access the network layer through the transport layer in some cases, and pretty much all applications have to do that, is a huge chunk of things you never really wanted to know in detail what they were actually doing and how they were coded. So the reason why you can't look inside here is because YouTube might actually decide to ban this video if I showed what you'd find in there. And this is a significantly bigger problem that just, configuring a couple of routers and maybe sorting out your network topology or whatever. Fixing all these applications is a problem. And even that is still only a small problem, because I have yet another diagram of the TCP IP stack which explains the problem even better. It starts with the same thing again, but slightly smaller, because the real problems are not even in the application layer. The real problems are on top of that, layer 8. People who actually have to use computers, operate computers, develop software for computers, users, developers, admins, all these people. Because they have to learn about IPv6, they have to come to grips with it. And, well, as far as I know, there is no way to do a quick software update on users. Would be great if there would be, but well, no luck so far. And these people all have to learn a lot. And yes, that even applies to end users at their skill level, sort of thing. Yeah, you don't want to call it like that with end users, but still, that's what we're talking about. And that means we have to get a lot of people up to speed with IPv6. And if you have a situation like some, for example, banks, they're pretty notorious about this. We have 30-year-old COBOL programs that actually made it through year 2000. And now you need COBOL programmers to fix things again. Because those people who did the job 15 years ago, they finally retired for good. Probably a lot of them are dead by now. And a lot of others are not in a shape to do any more coding. So there's a problem. And it's COBOL, can be Fortran. Well, there are more people still know about Fortran, but that's the problem. There's Algol, PL1, Clipper, Delphi, and whatnot. Rex, maybe? And that's where we have an enormous problem. And it's not a problem for the technical community, because hiring people, or trying to find people to hire, is job for management, for the non-technical management more specifically. They have to learn a lot about things, like, yes, with IPv6, IPv6 addresses are 4 times longer than IPv4 addresses, so your network traffic will be 4 times as fast. And whatever sort of nonsense some salespeople might come up with. Aside from that, management has to get resources, like COBOL programmers, like assigning the people they have to the jobs that need to be taken care of, and that means prioritization. Getting some money out, yeah, sure. But money is actually, well, it's always a problem, but it's quite likely not the biggest one if you have to deploy IPv6 in a rush. Then it's time, and you can't buy time for money, really, no matter what Ben Franklin ever said. And that's where things get really interesting. And for this reason, because with every day passing, IPv6 gets less of a technical problem and more of a time problem. It becomes less of a technical thing and more of a management thing, because dealing with times and priorities is not a job for the technical people. And even that's not the end of the story. On top of that, we have politics. Yeah. So what are politics doing in here? Now, the reason why politics are important is because there's legal things that have to be taken care of. A lot of laws and international agreements and whatnot are inherently based on assumptions that are correct with IPv4, but not necessarily with IPv6. And there's some public funding campaigns to promote, well, broadband things. I've been talking about that before. But IPv6 as well, yes. Actually, one of the early IPv6 implementations that got my attention was for the BSDs, FreeBSD, NetBSD, OpenBSD, and that was heavily funded by the Japanese government some 15 years ago or so. And that's where a lot of things have to happen. There's legislation, law enforcement, scary stuff, and it's all pretty much politics. So people who are not actually managing a single company, but basically running a country or the world, if you want. Okay, and with all the heated discussions, do we need IPv6 or not, or should we do auto configuration or DHCP for address configuration? There's a tremendous potential for pseudo-religious wars, so it's only a matter of time until the churches enter the game. Well, okay, hopefully not. But in any case, when I say that IPv6 is not a network topic, because the network topic, I mean, you can't see it here anymore. This is where the network layer is. This is really the smallest of our problems. The big ones are with the people, with management. And I've made a living for about 10 years now by teaching people about IPv6 mostly, and doing some consulting stuff and things. So yes, this is a huge job, and we're looking forward, well, I'm looking forward sort of to some rather interesting time where these things seriously pick up speed. Okay, so I hope you now believe me that IPv6 is not a technical thing any longer. Used to be like 10 years ago, but not today anymore. Today it's a management job. Hope you liked it. If you did and you watched this on YouTube, do me a favor and give it a thumbs up. If you want to discuss, come over to the forum at www.stepladder-it.com/bivblog/21, unless I'm mistaken. And in any case, hopefully see you again soon. Bye.